Because it's for Exergen distributors, we assume some basic knowledge on infrared sensor technology and how to measure temperature non-contact. Of course, these are very challenging times, and under normal circumstances, we would have loved to visit you and to talk to you personally, and bring you up to speed on what we've been doing, the latest product developments, the trends that we see in the market, the trends that you see in the market, how we can meet your needs better. But unfortunately, travel and visit is restricted, so we will do it in this online way. And again, we appreciate you all joining. These challenging times, of course, travels has been restricted. There were almost no events, but it's also given us time to focus on R&D, to listen to our customers, to listen to distributors, to see what needs are there in the market and what can we do to offer better products. And that is what we want to share with you in this webinar. I go to the next slide. Let's see, there we go. First, a little bit of housekeeping. We will have a roughly 30-minute presentation. Bob and I will do that together. Then we will have 20 to 25 minutes questions and answers. You can submit your questions in the toolbox below. There is a button Q&A. Please type in your questions. It could be that your question will be answered during the presentation, but if not, after the presentation, we will have time to answer your questions. We will go through all the questions and answer them. Should your question not be answered during this webinar, we will answer your questions via email. The aim is to have a pretty hard stop in 1 hour. Everybody's time is precious, and we should really round up in 1 hour. Should your question not be answered, we will contact you and we will answer your question. So what will, first of all, the presenters. I'll introduce myself shortly. My name is Bram Stelt. As of 2019, I am the CEO of Exergen Global, the global sales division of Exergen focused on OEM. I'm located in the Netherlands, so where I am now, it's 10 o'clock in the morning. I have over 10 years of experience in the infrared sensor market. I have a background in biomedical engineering, so I first started out in the company focusing on medical applications. That's still what I do a lot, focus on medical customers, but besides that, it's much broader, a lot of customers and applications in the graphics industry, plastics industry, semiconductor. We're in the Eindhoven area where there are quite a few big semiconductor companies. So it's very broad, and it's a pleasure to present to you today. My co-host today is located in Watertown. It's 4 o'clock in the morning there. Thanks, Bob, for waking up so early. Please, Bob, introduce yourself.
My pleasure. Good morning, good afternoon, good evening. My name is Bob Harris, Sales and Marketing Manager for Exergen Corp here in Watertown, Mass. I work directly here at the factory at corporate. Been working for Exergen for 25 years. Got my start, went to school at Northeastern University here in Boston. I got a bachelor's degree in electrical engineering, and I studied semiconductors and electro-optics. I was very interested in detectors and temperature sensors. And my first job out of college, I worked for a defense contractor where I detected missiles. We built sensors that detected missiles, so missile warning systems. And then shortly after that, I got a job at Exergen, and now we're detecting the temperature of anything from blood to webs in a printing process, human body temperature. And I've been working with Bram for the last decade. I've been working with Bart for the 25 years that I've been here at Exergen. And also I have the privilege of working with Dr. Frank Pompey, the founder of Exergen. So we have a lot of knowledge there, and it's great. It's been a great run, and I appreciate you all for joining us. And I think I've met a few of you over the years, and looking forward to many more years. And we're excited about this new product.
Thanks, Bob. Thank you. What will be the topics that we're going to talk about today? First of all, we're going to run you through a list of criteria to select the optimal infrared sensor solution. It's a selection of the most relevant criteria that we see in the field. Then we go to the market demands. What trends do we see in the market? What do customers expect from an IR sensor? And then we go to our novel product line, the AutoSmart IRTC line, that is our answer to these market demands and the changes in the market. I'll explain a case study of one of our key customers that is using this new product line. We will have a demo demonstrating you how it works. And then we will go into the question and answer session. But first, we will start with the criteria to select an optimal IR sensor solution. Bob, please.
Thank you. So the first criteria is called field of view, and field of view is defined as the ratio of the distance to spot size. For an example, a 4-to-1 field of view would mean if you're 4 inches away from the target, you would measure a 1-inch spot size. I apologize, I'm in the US, so I'm using English units. But so if you look at the scenarios here, you have bad, poor, and best. So if your sensor is too far away from the target, and you're going to measure some background if the spot size is too big. Poor is if the sensor is pretty close to the edge of the target. So if you're 4 inches away and you're measuring a 1-inch target, that's probably going to pick up some edge. So you're best to get a little bit closer. I would suggest getting about 3 inches away to get the best scenario for field of view, because that'll cover the spot will be in the center of the target, and you won't pick up any of the edge or any of the background. Also, regarding field of view, we have sensors that range in different sizes that have different optics. We could go from 1 to 2 all the way up to 20 to 1 optics. The smaller size sensors that are the least expensive have the widest field of view. For example, the micro IRTC that I'm sure you're familiar with. And then we have others like the 20 to 1, an IRTC 28, for example. It's a very large sensor that has a lens and very expensive detector, but you can measure, 20 inches away, you can get that 1-inch spot size. But it is also a large sensor. Next slide. The second criteria is your target temperature range. We have sensors that will cover temperature ranges all over the place. We can do medical applications where you need to measure, say, between 30 to 40 degrees C. We could do printing applications where you may be, between 100 to 140 degrees C. And then we also have applications where you're measuring very high temperatures like molten metals, where you could be.
We seem to have a little difficulty with the connection with Bob. Let me take over from here, see if Bob comes back. So Bob was telling that various temperature ranges, which is an important criteria for sensor selection. The medical range is a very small range, so it's maybe from 30 to 50 degrees C, but there are applications in drying applications where it can go all the way up to 250 C. There might even be in the steel industry all the way up to 2000 C. But it's a very important criteria to see what is the temperature range of interest, and then it could be a wide range, but generally there is a smaller range that's really the critical range. So it could be that the customer wants to measure from 0 to 250 C, but that around 170 C, that's the real critical range. That's when in drying applications, for instance, the substrate is really drying. So in the IRTC, we cover this by using various calibrations, temperature calibrations. The IRTCs are nonlinear, and in these calibrations, we kind of put the nonlinear signal on top of the linear signal. So in these ranges, in the red bars, this is where an IRTC is within 2% linear of a standard thermocouple signal. So for the various applications, you need various temperature ranges. For instance, the 180F90C is most accurate between 60 degrees Celsius and 105 degrees Celsius. So with this, you can cover the multiple temperature ranges that are required in the field. For higher temperatures, we have the adjustable modes. Another important criterion for the sensor selections is, of course, accuracy and repeatability. Accuracy in this way is how close a measurement is to the true value. In order to know that, you need to know what the true value is. The repeatability is how well a sensor gives reproducible results under identical circumstances. So it should give consistent reading over and over and over again. The accuracy is really dependent on environmental factors that can affect the accuracy, ambient temperatures, noise from surrounding areas, field of view issues, can be anything. The IRTCs in this way are really a high-end product, highly accurate and highly repeatable because of its unpowered nature. There's no power supply, there is no drift. So both on accuracy and repeatability, they score very high. And what you see is that in for instance, medical applications, it's really important that there is a high level of accuracy because it concerns patient safety. So accuracy is really important. In other applications, maybe in some drying processes or in plastic industry, it could be less of an issue. But what you also always see in OEM applications is that the repeatability is really key. You need to have consistent readings. Another criterion is the output signal. The IRTC line as we now have, it generates a thermocouple output signal. But of course, in the field, you see other output signals. It could be 4 to 20 milliamp, could be 0 to 10 volt, it could be 0 to 5 volt. Also, we see more and more demands for digital signals like I2C or I/O output. It really depends on what kind of system the customer has, and ideally, it should be kind of a plug-and-play principle. In general, the bigger machines tend to have a 4 to 20 milliamp or 0 to 10 analog outputs because there is a bigger chance, because the signals run over bigger distances, that there is electromagnetic interference. And of course, there is the sensor size that is an important criterion for the sensor selection. Right now we have various models, from the smallest one, the micro IRTC, to the bigger one, the IRTC 10, and it really depends on what kind of machine or what kind of application does the customer have. If it's a small one, again, medical is a good example where space is limited, so they cannot really use big sensors, so they need to have a small solution. In other examples, one is, for instance, in a paper mill where we supply the IRTC 5. It's a machine of 100 meters long, 50 meters wide, and 20 meters high. Of course, there's much more space available, and there's a need for a bigger and bulkier and more robust sensor. So they can use a bigger sensor. Now, we talk to customers, distributors, almost on a daily basis. So we have a very good idea of what the demands are for infrared sensors and what the trends are. But still, we thought let's ask the market, what do you want to see in the temperature sensor of the future? If we developed something, what kind of specifications should it have? So we performed a survey. It's been a pretty extensive survey with a lot of questions. We sent it out to many customers, distributors, relations. Quite a few of you have also filled in the survey. Again, thank you for that. And it gave us a very good idea of what the market demands were or are. We received over 150 respondents, so we think it gives a very good idea of what the market wants. I'm going to share a few outcomes with you, kind of in line with the criteria that we just discussed. This is what we see as trends in the market. I'd be very curious to hear from you. If you agree with this, if you see other trends, if you see other requirements, please let us know, because we're always looking for what the market wants and how we can offer solutions for that. The first thing that we asked is, what kind of field of view do you want a sensor to be? And what you see here is that in general, the market is looking for more narrow field of view sensors. What you see here is the yellow bar and the red bar and the green bar. They all represent field of views of smaller than 25 degrees. 25 degrees is approximately a 3-to-1 field of view. So the market wants 3-to-1 field of view even smaller. The red bar, which is 42% of all respondents, wants a field of view between 5 and 10%. And that's roughly a 5-to-1, 10-to-1 field of view. 10-to-1 is 6 degrees. So there is a need for more focused field of view sensors. If you look at the temperature range on the right side, we asked, what kind of temperature range do you need the sensor to be? And here the answers are more spread out. It's more evenly distributed. So there's not a real clear winner that we say, hey, that's the most desired temperature range. And this outcome really reflects the variety of different applications in which the sensors are used. So here a real, let's say, a lot of options are required to select the temperature range of interest. If you look at accuracy and repeatability, in both cases, the demands are pretty high, actually, which is good. If you look at the accuracy, the red bar is 37, almost 40% of all respondents wants to have an accuracy that is between 0.1 and 0.5 degrees C. That's already pretty accurate. The green bar, almost a quarter, well, over a quarter of the respondents wants to have an accuracy of 1/10 of a degree Celsius or better, and that's pretty demanding. That's not easy to achieve. Repeatability shows kind of a similar trend, where the red bar, over 30%, wants to have a repeatability between 0.1 and 0.5 degrees C, and the green bar, almost 40% of all respondents wants to have a repeatability of 1/10 of a degree or better. That's quite challenging to achieve. That's not easy, but we're always up for a challenge. We also asked, what kind of output signal would you prefer? And here there's a clear winner. You can see here almost half of the respondents is looking for an output signal 4 to 20 milliamp. So that is clearly the most desired output. After that, kind of more or less evenly distributed are I2C, the digital output, Thermocouple, what we offer now, 0 to 10 volt, and other. If you look at all the outcomes from the survey, because I've discussed 5 now, but I think we asked over 20 different parameters or variables. What we see is that flexibility is needed in the products that are offered to the market, because each application has its own specifications. So there is not one single product that covers all the requirements. So flexibility is needed. What we do see is that almost all of them require high accuracy and a high repeatability. And this is the challenge that we took in developing a new product. And this is where we come to the AutoSmart IoTC line. This is a product that we launched the end of last year, where we basically combine the performance of the IRTC with the smart conversion of a AutoSmart transmitter. To meet the requirements of the market, of the high accuracy and the high repeatability, we took the performance of the IRTC. So the IRTC in terms of accuracy, repeatability, reliability is very good. It can have an accuracy up to 0.1 degrees C. If you're on the calibration point, it's even 0.01 degrees C. The resolution of the IRTC itself is 0.001, which is the Johnson noise, because it's unpowered, so it has extremely high resolution. The repeatability error is very small, 1/10 of a degree, so this meets the market demands. However, also to offer the analog output signals, we developed an AutoSmart transmitter where we convert the thermocouple signal of the IRTC into an analog 4 to 20 milliamp or a 0 to 10 volt output. And it's also linearized. So where the IRTC is nonlinear, here the signal is linearized. So it's much easier to use. This gives the performance. We also wanted to give the flexibility that is desired in the market to meet the various demands of the different applications. We offer this by allowing any IRTC to be connected to the AutoSmart transmitter. So you can select an IRTC on field of view mostly, could also be size, of course. But the IRTCs that can be connected to the AutoSmart vary in field of view from 1 to 2, the micro IRTC, which is approximately 110 degrees, a very wide field of view, to a more focused 10 to 1 field of view, or 6 degrees. We calibrate this on the AutoSmart transmitter in 3 standard temperature ranges. You can select from these. So you can select 0 to 30 degrees C to 70 degrees C, 0 to 100 degrees C, or 0 to 250 degrees C. Those are the options. But it's also very easy to customize it. In the demo, we will show you how that works. But this temperature range can easily be customized for specific applications. You can choose the output signal. So the 4 to 20 milliamp and the 0 to 10 volt are standard. You can always, any AutoSmart has these standard as output signal, but you can also choose 0 to 20 milliamp, 0 to 5 volts, 0 to 2.5 volts, 0 to 1 volt. We are working on digital solutions. We hope to present that later this year. And you can basically connect any cable length to the AutoSmart transmitter to meet the needs and the demands of the customer. I'd like to tell you about a case study of Kodak. This is one of the first customers that employed the new AutoSmart IRTC line. You all know Kodak. Kodak, well known for the films in the analog cameras. They have a lot of knowledge on imaging, on how to put an image on a paper or on a substrate. And they use that knowledge, those patents, that IP, to go into the digital printing market. And this is a very competitive market, where they want to compete with companies like HP, Xerox, Heidelberg, Lambda is a company that is coming up. And in order to compete, they were developing a new machine, the UltraStream 520 printing press, that is high speed, has a high resolution, very high quality of the print, and reduced ink usage and also energy usage. Now, you can only achieve this in your machine if you have a very high quality thermal management system. So Kodak, they contacted us and they said, look guys, we're developing the fastest machine on the market, 500 feet per minute, or 2,148 pages per minute, which is 2 to 3 times faster than the competition. Again, this is only achievable if you have a well-controlled process, a well-controlled system. And thermal management is a big component on that. To reach that speed, along with the quality, they need to know when the ink is dry. So the ink is transferred on the paper, it needs to be dried, and that's the speed limiting step. So they have 4 intelligent infrared drying units in the machine to dry the ink. And these units are controlled by the AutoSmart micro IRTC sensor with the air purge. You see in the right corner the air purge, which is used to cool and clean the sensor, because there's a lot of ink particles in the machine. But Kodak said, look, we need a solution that is A, fast, B, very accurate, C, it needs to be really small, and the machine is pretty big. We have long cables running through the machine. There's a lot of noise, so it needs to be a 4 to 20 milliamp output signal. So the AutoSmart solution is the ideal solution for them. They have integrated it. It's a bit difficult to see in this picture, but here in between dryers is where the sensor is located. It's underneath the bracket. You see there's not a lot of space available, so it also needed to be a small one. So Kodak is using this now, and they have high expectations of the machine, and so do we. It's recently launched, so this is a good example of where the added value of the AutoSmart IRTC line is really coming out. Now I'd like to give you a demonstration of how the AutoSmart sensor line works. As explained, you can connect several IRTC sensors to the AutoSmart transmitter. What you see here is the micro IRTC, which is connected to the AutoSmart transmitter. In the back of the AutoSmart transmitter is an M12 connector. And with any AutoSmart sensor that you order, you will get a cable, of course, with a fitting M12 that you can very easily connect to the AutoSmart. Like this, very solid, very reliable. In principle, you can order any cable length that you desire. At the end of the cable are 4 wires. The brown wire is the power supply, 12 to 28 volts. The blue wire is the ground. The white wire is the voltage output, and the black wire is the current signal output. Another example here is the IRTC01. Again, this is an IRTC model connected to the AutoSmart transmitter. Now, for this demonstration, I have set up some equipment to demonstrate how it works. So, in this case, I have installed here a PID controller. It's a Euroterm controller. Inside, I have a 24 volt power supply, and in this case, we use the current signal output 0 to 20 milliamp corresponds to 0 to 100 volts. What you see is already, if I put a warmer target in front of the sensor, you see a result in the screen. Also here is a black body calibrator. So I would like to demonstrate how this works. I put the sensor in front of the black body, make sure it's mounted properly, looking in the right direction. And you see that it gives a very nice temperature of the black body. So if you order an AutoSmart sensor with a standard calibration, so minus 30 to 70 degrees C, or 0 to 100 C, or 0 to 250 C, this is how it works. There's also a possibility to do a custom calibration. Let me demonstrate to you how that works. For a custom calibration, you need our special syntax calibration software that comes with the AutoSmart IRTC line. What's also very important is that you have a reliable reference temperature sensor. In this case, I am using a specially calibrated, certified K-type thermocouple sensor that goes to AutoSmart calibration. device. I put the reference sensor here in the black body to give an accurate measurement of the black body temperature. And I plug in the stick, USB stick, into the laptop, and you immediately see that the software recognizes the reference sensor. What you also see is that this is a contact sensor. It came from a somewhat colder environment, so this one takes some time to adjust. In practice, you also need to give your reference sensor time to adjust and take the temperature of your target. For this demonstration, I will use the micro IRTC connected to the AutoSmart. I've already plugged in the M12 connector. And in this case, instead of the 4-wire output, I have the USB stick. As soon as I plug the stick into my laptop, it's recognized by the SendTalk software, and you should immediately see the sensor popping up in the screen. There we go. Now I install the sensor in front of the black body, make sure it's aligned properly. There we go. This one will give a very nice measurement very close to the reference sensor. In customizing an AutoSmart IRTC, there are several things that you can customize. You can customize the output, you can customize the temperature range, but what makes this software so useful is that you can adjust the sensor reading to match the reference sensor. Let me demonstrate how this works. You see, by the way, the screen that the two measurements are really nicely aligned right now. But in this case, just for the sake of purpose or example, I'm going to just put the sensor at an angle. Let's say you have an application where the sensor is maybe measuring obliquely. Now you immediately see an effect in the reading, where the sensor now, because of field of view issues, is giving a different reading than the target and the black body, because there are other things in the field of view that affect the reading. But I can adjust for this. Let me show you how that works. So here on the software, I click. Now, my reference sensor is 39.9. I put in the 39.9 value here, the software, and then I press Auto Adjust. And then you will see the AutoSmart transmitter will automatically adjust the sensor reading to go to the set value of 39.9. And now, even though the sensor itself might be reading a slightly lower temperature because of field of view issues, it still gives a very accurate temperature reading as compared to the reference. And as long as in any application, the environments are reproducible, the sensor will give you reproducible results. So now this sensor is custom calibrated. What you also see in the software is that you can very easily adjust, let's say, the output. You can choose 0 to 10 volt, but you can also select 0 to 5, 0 to 2.5, 0 to 1 volt. Here you can easily select 0 to 20 milliamp or 4 to 20 milliamp. You can adjust the temperature range. So this is all very easy and very convenient to do a custom calibration. And again, as long as the application and the process is reproducible, the sensor will give you reproducible results. Okay, I hope that was clear, and it gave you a good understanding of what the capabilities are of the AutoSmart. Oh, I have to stop this. Sorry. Again, if you have questions on this, feel free to ask them in the Q&A toolbox below. The last thing that I want to show you before we go into the question and answer session is another example of how we customized the AutoSmart specifically for a requirement of a customer. In this case, the customer is a research institute for agriculture and greenhouses, and they said we need to measure the temperature of leaves of certain crops because we want to know how much we need to irrigate them to optimize the yield and to also see what effects different lighting protocols have on the development of the plants. So we need to measure a leaf, but a leaf, it changes position. It can change it overnight during the day, so it's kind of moving. So we need a sensor that we can easily adjust the position of. That is why we added the flexible gooseneck to the sensor. You can see here that you can easily adjust the sensor to aim it towards a leaf, and if it changes a bit, you can easily adjust. We also added the white special housing. This protects the sensor from direct sunlight and overheating so that it stays really stable. It's IP67 rated, so water resistant. It comes with a clamp so that you can put the sensor on any stand or some fixture to mount it. And what you see in greenhouses or in the agriculture is they use a lot of sensors, and usually they have data acquisition boxes where they gather all the data from the sensors, but these can be positioned tens of meters away from where the sensor is. So they need a very long cable, and in this case, you need to have 40 to 20 milliamp. First of all, it's much more stable, and second of all, it's much more cost efficient than a thermocouple output. So for this one, we designed a really specialized sensor based on the AutoSmart. This brings us to the end of the presentation, where I hope I have demonstrated how the new AutoSmart IoTC line really meets the market requirements. On one side is the accuracy and repeatability, and on the other side it's the flexibility in terms of temperature ranges and output signals. You can find product information on our website. I will share this presentation with you, so you will have the link, but also please go to the website. You will find the AutoSmart IoTC line. We're going to the question and answer session right now, so any questions, please put them in the dialog box below. We have, let's say, roughly 20 minutes left for questions. I try to answer all the questions. I already see quite a few popping up. I hope I have time to answer them all. In case your question is not answered, I can promise you I will answer it by email, or I'll give you a call. That's also a possibility. If you have any inquiries or any applications or any questions, please contact me, contact Bob. We're very, very eager to hear your response, first of all on the webinar, but also what you think of the product, what opportunities you see, and also what you think we should focus on for further R&D, because we're always working on new products. Okay, thanks. Thank you. What I'm going to do now is look at the Q&A box. Okay, thanks. I already see some questions popping up. I see, of course, we didn't expect that question. The prices for this line. What I will do is you will all, as distributors, receive the new 2021 price list shortly. Before the end of next week, we will have finalized it. The prices will basically be the same as 2020. There's no change in the prices. We managed to keep them stable. For the AutoSmart IoTC line, the price, it really depends on what IoTC model you choose to connect to the AutoSmart, because the prices in the IoTC models they vary. But to give an example and a rough idea, the micro IoTC, the smallest one, the list price of the AutoSmart is 579, and so the distributor price, all of you get a 30% discount, is a little over $400. I kind of expect you to think, hey, we see competitors that offer products at lower prices. Yes, we know that, but this product it's much better, much more versatile than competition. In terms of accuracy and repeatability, it's way better than all the competition. The flexibility it offers, the flexibility in both, the customized temperature ranges, the various output signals. It has much more added value, so that justifies a higher price. Please realize that we are working on novel solutions and also on a whole new product line where we hope we can inform you later this year, which we aim to be also very high performance, but at a very competitive price. But stay tuned, stay tuned. You will hear a lot about that from us this year. I hope that answers the question. I also see here in the chat box, let me check what we have here. Okay. The question here, thanks for the question. Who do you consider to be your competition? With our product range, we mainly focus on OEM applications. Of course, it's also for process automation. We believe the AutoSmart is even more suitable for process automation than the I2C line because of the ease of use and the output signals, the analog 4-20 0-10 volt output. In OEM applications, the competition that we see most is basically Optris. You all know Optris. A few of the models are quite small. We see quite a few of their models that have like a box where you need to adjust settings before you can use it. You can adjust offset, emissivity, I don't know what. But for OEM, that's not really suitable because customers don't want to adjust that settings all the time. But I'd say Optris is the biggest competitor. There's also Kalex. Kalex, if you look at their website, it's also more on process automation, we feel, where you can find sensors with displays, where you can also adjust some settings. These are also quite large, these sensors. So really for OEM, it's mainly Optris. I think AST is something that we see in Asia. I'm very curious to hear from you what kind of sensors you see in the market as competing sensors. I hope that answers your question. If not, here I have a question. Did I understand right that with the software syntax, the parameters for customizing are stored in the AutoSmart? Can one disconnect the device and put it in the application? And the answer to that is yes. So any settings that you change in the syntax software is stored in the AutoSmart itself. So yes, you can then disconnect the device and use it in an application. That's the whole idea. Maybe it's good to elaborate a little bit more on that. The syntax software that I showed in the demonstration is also what we use to calibrate all the sensors and to calibrate the models. So for the standard applications, -30 to 70C, 0 to 100C, 0 to 250C, what we do is we have the black body calibrator with a certified, very highly accurate reference sensor. And we basically let the temperature of the black body go from 250 back to 0. And a customized lookup table is generated that is put into the AutoSmart. So from 250C to 0C, I think every 100 milliseconds, there is a measurement that creates a data point. So I think there could be 50,000 data points. I think it's a 16-bit processor. There could be more than 50,000 data points from 250C to 0C, where it follows the reference sensor. So it gives a very high accuracy over the full range. And this This lookup table is stored onto the AutoSmart. But these, of course, are reproducible. If you take the same sensor and you put it, it will give you the same millivolt table. So these can be copied. If a customer says, for instance, the one in the greenhouse, the customer says we want to measure the leaf temperature. It's from 10 degrees C to 50 degrees C. I forgot to mention it in the talk, but it's custom calibrated from 10 degrees C to 50 degrees C. So within that small range, you have a very high resolution. We can do that in-house because the customer says, look, I want to have 4 milliamp output at 10 degrees C and 20 milliamp output at 50 degrees C. We do that in-house, also with a black body. So that is something that doesn't need to be done at the customer side. Only when a customer said, look, I have such a challenging application with some noise that's reproducible or repeatable, can be canceled out, then it's possible to do a custom calibration at the customer side. But the challenge there is to have a very good and reliable reference sensor. If you have a good and reliable reference sensor, it needs to be a thermocouple, not a handheld device would not work as well. You can basically make the sensor, the IR sensor, follow the reference sensor over a certain temperature range. And that again will be stored on the AutoSmart, not in the Centak software. I hope this answers your question. Thank you. Let's see. Thanks for all these questions. I have here one. In the Kodak case study, could we ask how many IRTCs are used for one machine? Yes, that is 4 sensors because I have 4 dryers in each machine. So there are 4 sensors in each machine. Each dryer monitors and controls the temperature of that one dryer, and then there's a feedback loop to control the power of the dryer. And by controlling the power of the dryer and measuring the temperature, they can optimize the speed. Here I have one. Can we use the AutoSmart for higher temperatures like molten metal, for which I am struggling for years? The adjustability feature in software will help match the reading of the customer. Yes, I think in theory this can be done. I have to say we've never done it on molten metal before. Of course, here you're talking about temperatures of, I think, maybe 2000 degrees in that range or even higher. And that means we would need to have an adjustable sensor connected to the AutoSmart. That can be done. And I think the challenge here is to see how to do a good reference measurement and create a lookup table for this customer. But I think I will contact you by email to figure out how we can do that. But the quick answer is yes, this is possible. The AutoSmart can be used for that. Let's see if we have some other applications or other questions. I'm just scrolling through the questions if I see any ones that are double maybe. Does this solution work with any controller, any PID? Well, basically, you know, any readout device, controller, data logger that has an analog output of 0 to 20 milliamp, 4 to 20 milliamp, or 0 to 10 volt, 0 to 5 volt, the ones that I mentioned, you can connect it. Of course, you will need to adjust the settings in the readout device. I mean, if the sensor is calibrated, let's say from 0 to 100 degrees, you have to make sure that in the readout device that is programmed so that the readout device knows, okay, 0 volt, or 4 milliamp corresponds to 0 degrees, and 10 volt or 20 milliamp corresponds to 100 degrees. And once you've done that, it basically works. So that should be really easy to install and easy to use. Here's another one. How much time do we have? Okay, roughly it's 8 minutes left. Can you elaborate on the accuracy and repeatability of 0.1 C? Does that apply to the entire temperature range? Yes, I can elaborate on that. As I tried to explain, accuracy is something that's not a feature of the sensor itself, because the accuracy also depends on environmental issues or factors that affect the reading. It could be field of view, could be ambient temperature changes, it can be emissivity, you know, dust, whatever. That all affects accuracy. The sensors are capable of measuring very accurately, and that is because the IRTC itself can measure very accurately. It has a resolution of 0.0001, that's really low. The resolution with the AutoSmart changes, but still the resolution with the AutoSmart is better than 100th of a degree. That has to do with the fact what I just said, is it's a 16-bit processor. So even in a temperature range of 0 to 250 C, you have more than 50,000, you have actually more than 60,000 data points. So each point corresponds to less than 100th of a degree Celsius. So your resolution is very high. That means that if you have a very accurate sensor, so the combination of those allows for very accurate measurements. And the fact that the sensor is calibrated from 250 C to 0 C, or even 100 C to 0 C, or whatever range you have, it's calibrated for the full range. You know, where you see a IRTC sensor as we have it now, we calibrate it for one point specifically, and away from that calibration point, accuracy diminishes because of linearization errors. With the AutoSmart, over the full range, every 100 milliseconds, so every 100th of a degree or so, it's calibrated. So yes, over the full range, we can meet the accuracy of 0.1 C. And it also accounts for the repeatability, because we can copy that calibration on each sensor. Well, that's basically the interchangeability, but it will be really stable. I think the limiting factor here, because you have an accuracy and resolution of the IRTC that is unprecedented. You have a resolution of the AutoSmart transmitter that is unprecedented. I think the limiting factor, but most affects the accuracy, is the reference sensor. How accurate is the reference sensor? In this case, what I demonstrated, we have a certified reference sensor. Out of the top of my head, I think it's certified to a 10th of a degree accurate. But if you do it at a customer side, the question is, how well can you do a reference measurement? I hope this answers the question. Let's see if we have more. The unit for measuring in the greenhouse, do you have more information on that? Absolutely, we do, and I will email that. I will share that. It's also on the website. We do see an increased interest from greenhouses. We actually sell quite a lot of sensors for measuring leaf or crop temperature. It's becoming a bigger market for us, so we are looking for more solutions for that field. And the one that I demonstrated today with the gooseneck is just one of them. More products will follow that are aimed at agriculture and greenhouses, and I'm happy to hear that there seems to be an interest for that. Let's see some other questions. What is the most used output signal in medical applications? We see in medical applications, in my experience, that they're pretty well off reading the thermocouple output or the IRTC. What you see is the medical device is very small. You know, in general, it's a very small device. So there's not a long distances that signals need to cover. There's not a big chance that there is a lot of electromagnetic interference. So millivolt actually works quite well. But in the medical, we also see more and more digital outputs. The I2C output that you also saw in the outcomes from the survey, I think that comes from a few medical companies, and this is something that we're working on. Again, we're focusing on R&D, and we hope to have new product announcement later this year, where digital outputs are added to the solutions that we have. Let's see. Where is the line being manufactured? USA, Europe, or Asia? It's a good question. The IRTCs, the sensors themselves, are manufactured in the facility in Watertown of Exergen. But the AutoSmart line is actually developed by Exergen Global, so the Dutch division. That's manufactured here in the Netherlands, and the assembly of the IRTC and the AutoSmart and the calibration is done here in the Netherlands. So any orders you might have will be shipped from the Netherlands. Lead times are, let's say, 2 to 3 weeks, so like the normal lead times. I also saw a question about minimum order quantities. Basically, the minimum order quantity is 1. If you have a customer that wants to try one, we can offer it. For really customized solutions, we have to look if one is really feasible, but it's something that we can do and look at it together. I see it's almost 11 here, so the hour is almost complete. Let me scroll to some questions. Again, in the agricultural case study, can we assume that the IRTC could also be used outdoors? Yes, it can be used outdoors. So that's why it has a special housing to protect it from direct sunlight and overheating in that way. It's IP as 67, so it's watertight. What you do have to account for is that if it's really wet and water remains on the lens of the sensor, it will affect the reading. We see most customers, if they apply the sensors outdoors, and it's done because they're also used in fields, to measure more general, not just a leaf temperature, but a more general crop temperature. But then they place the sensor under some kind of a protective cover, so that it's protected from rain and also direct sunlight, and it gives the best readings. I see here this is the last one that I'll answer. I see there are some more questions asked. I will answer them by email. I'll make sure all the questions are asked. I'm happy to see so many questions, that there is an interest. The last one that I will ask is a comment about the price, that it's pretty high, not competitive. What do we expect to do about this? Well, as I tried to explain, it is high, but it's also the added value is much higher than what we see in the market. So it's really for applications where accuracy, repeatability is key, or customization is really required. Another example is in frozen mushrooms, where we measure these when they come out of a freezer, which is, I believe it's minus 25 degrees. There are very few competitors that can do this. But again, we're working on new product lines. Later this year, we will really hope to be able to inform you of our latest products, latest developments, and of course there the price performance ratio is key. So stay tuned to that. And with that answer, I'd like to round up. The hour is finished. Again, thank you all for attending, for your time and attention, for all the questions. Any questions that I did not answer, I will answer them via the email. So I wish you all a very nice day, a very nice evening. I'm sorry we lost Bob early in the webinar, but it happens, and I'm happy we managed to proceed like this. So thank you very much, and hope to talk to you all soon. Have a good day. Bye-bye.
Thank you, everybody. Stay safe.